So we're going to work on some sigma notation practice here. Remember that sigma, this Greek letter, is called sigma, and sigma means sum. So we're working with series and we're adding things up. So for number 1 and 2, we are going to be evaluating each sum that's written in sigma notation. It wants us to write out each term in the expansion. That means we would need to know what the first term, the second term, the third term is, so on and so on, that we're adding up. So when I look at number 1, it says the sum from the 4th term to the 9th term of 4 times 3 to the n minus 1. First of all, it doesn't ask us this, but just so we know, this is a geometric series because it's using a geometric sequence formula. So it tells us to start with the term n equals 4. So for n equals 4, that means we're going to put 4 in for n in the exponent. So I'll have 4 times 3 to the 4 minus 1 power. You can go ahead and type that into your calculator, 4 times 3. I would put 3 in parentheses when you use your calculator. But that gives you 108. So that is the 4th term of this sequence. You keep doing the same thing for n equals 5. So write 4 times 3 to the 5 minus 1 power, which is 324. And so on and so on and so on. So I want you to do that here. I want you to go ahead and hit pause. I want you to type the values for n into your calculator, 6, 7, 8, and 9, and then we'll come back together. All right, so go ahead and hit pause, and I'll just continue writing things down here. Okay, we have n equals 6, 4 times 3 to the 6 minus 1 power, which is 972. N equals 7. N equals 8. And finally, n equals 9. All right, now, once you have all of these terms, you are going to take the 4th term, 5th, 6th, 7th, 8th, and 9th term and type those into your calculator. Add them all up. If I add these up, they're going to equal 39,312. That is the value of the sum, and we showed each term in the sequence. All right, we're going to do the same thing for number 2 here. Number 2, notice it is arithmetic based on the sequence formula that I have. Let's get practice identifying those. And we're starting with n equals 1. So here, if I'm going to write out all the terms, I'm going to put 1 in for n to start. So 2 minus 3 times 1 is negative 1. Same thing for n equals 2, 3, 4, and 5. So go ahead and hit pause, find all those values of the terms, and then check back to see if you got the values right. Okay? So for 2 minus 3 times 2, which is 6, is negative 4. All right, so once we have those values, just like the first problem, we're going to add up all of these terms that you just found. So you're going to add up negative 1, negative 4, negative 7, negative 10, negative 13. Add those up, find the sum of them, and the value is negative 35. Okay, so it's a lot of writing, but it's important to understand what is happening when you're using sigma notation and finding the sum. So as we move forward, 3, 4, and 5, we are going to evaluate each sum. It says we have to show all of our work. That means you cannot just type this sum into your calculator. We want to make sure that you understand the process of finding a sum. Okay, so we have our sum formulas here. I'm going to move it on to this side. We have our sum formulas over there that we're going to use. And the first thing we need to remember is, first we need to identify what type of sequence we are using. Okay, we have here 42 minus 9k. This is arithmetic. So that means when I do this problem, I'm going to be using one or both of the arithmetic sequence and series formula. Now, in order to use this series formula, because ultimately that's what we're going to be doing is adding things up, the series S sub n, I need to know what n is. N is the number of terms that you're adding up. So that's where I would start. I would find the n. How many terms are you adding up here? Now remember, on our notes, the way I said to find the number of terms you're adding up is to take the top number, the index of 22, minus the bottom index of 17, and then add 1. Well, 22 minus 17 is 5, plus 1 is 6. So 6n, we're adding up 6 numbers, 17, 18, 19, 20, 21, 22. So now in order to use this formula, I need to find what we're considering the first term and the nth term. So our a sub 1 here, the first term we're adding up, is really a sub 17. Okay? Now the nice thing is, I don't need to use the sequence formula up here because I'm given the sequence formula in a simplified form in the expression. So I'm just going to put 17 into that formula here. So you'll have 42 minus 9 times 17. Go ahead and type that into your calculator. And when you do that, you get negative 111. That's the 17 of a sub 17 of this sequence. I'm going to do the same thing for the top index here of 22. That's my a sub n. So I need to find the last term I'm adding up, which is the 22nd, and put 22 in for n. That gives me negative 156. Well, now between those three things I just found, I have enough to evaluate the sum using the sequence formula, the sum of those 6 terms. All right, so n is 6, so I have 6 over 2. I take the first term I'm adding up, which is the 17th, negative 111, plus the last term I'm adding up, negative 156. Let's type that into our calculator. And remember, we're going to type that in pretty carefully. Okay. So we have 6 over 2. You could simplify that to 3. That's fine. We have negative 111 plus negative 156. When you type that into your calculator, you should get that the sum is going to be negative 801. So that is the answer here. Good work. So you have to show all that work for these 3 problems. So let's look at number 4. Number 4 is also arithmetic. It's set up the same way here with an arithmetic formula. So again, you're looking at the top 2 equations over here for arithmetic. More specifically, we're going to be using S sub n for the series, the sum. Now, just because we just did number 3, I would like you to hit pause and try this problem on your own. If you need help, I will walk through and explain. Go ahead and hit pause now and give it a shot, and you can come back and check your work. So the first thing we need to do here is find n. How many terms are we adding up? So remember, you're going to take the top value, the top index, minus the bottom one, and add 1. Well, 28 minus 14 plus 1 is 15. You're adding up 15 terms of this sequence here from 14 to 28. Now, in order to use this series formula, you need to know what is the 14th term and what is the 28th term. So that's the next thing I would do. Find the 14th term. That's where you're starting, your first term here. So you'll have 2 times 14 minus 50. That is negative 22. Then I need to find the last term I'm adding up, a sub 28. That 28 is going to go in for n. We have 56 minus 50, which is 6. Those 3 things are enough to find now the value of the sum written out in my series formula. Right? So you're finding the sum of these 15 terms. So that 15 goes in for n. The first number you add up is negative 22, and you're adding up through the term 6. So just like the last problem, let's carefully type that into our calculators. So you have 15 over 2. And again, our first term was negative 22. And we're adding through 6. That tells us that the sum of this series is negative 120. All right, one more here, and then we'll speed it up with our calculator. So I'm finding the sum from 1 to 6 of 2 times negative 3 to the n minus 1 power. First thing we need to be aware of is that this is a geometric sequence. So I'm using the bottom 2 formulas over here this time. Again, more specifically, you're going to be using the series formula, S sub n. Now, in order to use this S sub n formula, it looks like I need a sub 1, I need r, the common ratio, and I need n. So let's find n first. Remember, n we find using the indices of our series, or our sigma notation, I'm sorry. So of 6 minus 1 plus 1, which equals 6. Okay, so we're adding up the first 6 terms. Now I need to find the first term, a sub 1. Well, a sub 1 I can find by putting 1 into my formula here that's in sigma notation. So I'll have 2 times negative 3 to the 1 minus 1 power. That gives you the value of 2. Right? 1 minus 1 is the 0 power. Negative 3 to the 0 is 1. 2 times 1 is 2. All right, and our common ratio we can find by looking at our expression. That's what's in the parentheses, and that's negative 3. So now we can go ahead and use our sum formula to find the sum of these 6 terms. So I start with the first term, which is 2. That's a sub 1. Your expression is 1 minus the common ratio, and that's the common ratio raised to the nth power. How many terms are you adding up? All over 1 minus the common ratio. Now the trickiest part of this is that you have to make sure you use the correct parentheses and the correct notation. But now you can type that straight into your calculator. Just make sure that you are careful with your parentheses and that the 6 goes outside of the parentheses of the negative 3, but within the parentheses of that top quantity. And then your denominator is 1 minus negative 3. You should get, when you add up all those terms, 1 through 6, a sum of negative 364. Okay. Let's switch it up. Let's do a multiple choice question. We want to know what is sigma notation to represent this sum. Well, first things first, it looks like when I look at all the sigma notations down here, these all look arithmetic, so let's double check. Arithmetic means you're adding or subtracting the same value every time to get from term to term. And it looks like from 32 to 35, I'm adding 3. I'm adding 3 again. It does seem to be the pattern that it is arithmetic, and we're going to have a common difference of 3. So when I have a common difference of 3, think about how you would write your expression. You would say a sub 1 equals the first term plus 3 times the common ratio. Well, you could write out that whole expression. You could say a sub n. You could find the a sub n formula. We can do that here. And then I'll show you a shortcut. So I have the first term of 32 plus our common difference times n minus 1. If I distribute this, I'll have 32 plus 3n minus 3, which gives me 29 plus 3n, which doesn't necessarily match any of the formulas. However, I want to point out something to you. Notice that the common difference is the coefficient on the end, which means that it's going to have to be one of these expressions, because here's the thing. We technically don't really know that 32 is the first term. Is that a sub 1? I assumed it was over here, but we don't really know that. It's just giving us part of a series. All I do know is that the common difference is 3. Okay, so I know that it's not going to be D and it's not going to be C, because their common differences would be 1. Okay, so I know it's A or B. Now, Now, when I look here, the next part is just being careful. When we use sigma notation, the indices, the numbers, the terms that we're going between, the bottom index has to be lower than the top index. You have to go from adding up the lower term to the higher term, which means B is the only answer that would make sense here. They have the same equation, but you have to add up from 11 to 34. You can't add up from 34 to 11. So that's being careful with your indices. Now let's make it faster. For all these problems on the back page, you are allowed to use your calculator to evaluate the sum. So let's review that. You're welcome to use the formulas, but it's going to take a little bit longer. So we have evaluate the sum from n equals 11 to 30 of n cubed plus 2. Well, first of all, I can't even use one of my formulas because that's not arithmetic or geometric. So here's where my calculator is going to help me out. Let's review. To use your calculator, you hit math, and then you're going to go to the value of 0 here. I'm just going to type in 0 usually, but you're going to go to 0, which is summation. When you use the summation, even if on your paper it says n equals, you have to use the variable of x. But now you just type in exactly what you had from the term from 11 to 30. And in parentheses here, again, instead of n, you'd use x cubed plus 2. When I hit enter, it gives me the value of the sum. The calculator did all of the work for us, 213,240, which is B. Same thing in number 8 here. I have the sum from 1 to 10. And let's see. I'm going to again type this into my calculator. So I'm going to go to math, type the number 0, use x. My sum is only going from 1 to 10, so I put in those index values. And I type in 7 minus 2x. Now this is arithmetic, so you could use the formulas here, but I think it's a lot faster to type it into your calculator and get a sum of negative 40. Okay? All right, so that's pretty easy, typing those in for a multiple choice question. Now we need to write the sum in sigma notation, and then we can evaluate the sum either by hand using the formulas or using our calculators. I'm going to use our calculator. Okay, so the first thing we need to do is identify what type of sequence this is, or what types of series, I'm sorry. So you have to decide, are you adding the same value every time or multiplying? Here it looks like I'm adding 1 every time, so this is going to be arithmetic. Okay. So since this is arithmetic, I'm going to use the sequence formula in order to write the simplified formula for the sequence that I can use in my sigma notation. Okay, so a sub 1 is 1, so I have a sub n equals 1. That's my first term, plus my common difference of 1 times n minus 1. Now I need to simplify this, which means get rid of the parentheses. So I'll have 1 plus 1n minus 1. And notice here the 1 and the negative 1 cancel off. So your formula is just 1n or n. Well, that formula is what goes into your sigma notation. 1n, or just n here. But you have to put index values on here. What number are you adding up between? Well, it appears that this is our first term. So we're adding up from n equals 1. And you can probably gather that up to 100, 100 is going to be the 100th term. So now you can type that into your calculator. All right, math 0 from term 1 to 100 of, remember, x instead of n. And you should get 5,050. That's it. That's the whole thing we need. We need the sigma notation and the value of the sum. Let's look at 10. 10, let's see, it goes from 12 plus 5 plus negative 2. So we're decreasing. It looks like I'm subtracting 7 every time. So this is going to be arithmetic as well. So arithmetic, again, you're going to use your sequence formula to help you find the simplified sequence equation, A sub n, and then put that in your sigma notation. So here's what we have. The first term is 12. Our common difference is negative 7, so we're going to have minus 7 times n minus 1. And I'm going to simplify this expression here to be 12 minus 7n plus 7. And the 12 plus 7 give me 19 minus 7. Well, that's the sequence formula that now you're going to use in sigma notation. Right? You're going to have 19 minus 7n. Well, our index here, our low index, starts at the first term. And then here, I don't have any dot, 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 so I can count. This is the first term, second, third, fourth, fifth, sixth. So you're only adding up 6 values. All right, so go ahead, type this into your calculator. Math 0. We're going from term 1 to 6 of the expression that we here we go, just wrote 19 minus 7n, but we use x. We should get negative 33. Now there is a way here, it would have been just as easy, is to type each of those values out into your calculator. But remember, we're practicing writing sigma notation. All right, number 11, negative 4, 8, negative 16, 32. Well, this is going to be geometric, and I'll tell you how I knew that really quick. First of all, you are going to be multiplying to get from term to term. But when you see alternating signs, negative, positive, that means it's going to be a geometric, and you're going to be multiplying by a negative. Remember, if you're having trouble finding the common ratio, you take the second term divided by the first, which gives you a common ratio of negative 2. Well, since this is geometric, I'm going to use my sequence formula for a geometric sequence. And this one's pretty easy to come up with because we have a sub 1, which is negative 4. We found a common ratio of negative 2, and it just goes to the n minus 1 power. So that's all the work you have to do, because now you are all set to put this into sigma notation. You take your expression that you just wrote, put it next to the sigma, and then we have to figure out what terms are we adding up. Well, negative 4 is our first term, so we're starting at term 1, and it says we're adding up until term 10. So now it's pretty quick to type into our calculator. We're adding up from 1 to 10, and we're going to carefully type in our expression negative 4 times negative 2. Remember, our exponent is x minus 1. Hit enter, and the sum of all those terms is 1,364. So this is what we are looking for, the whole expression. All right, 2 more to go. Number 12. 3 plus 6 plus 12 plus 24 plus 48. It looks like we are multiplying by 2. Since we're multiplying, this is going to be geometric. Right, I'm going to speed this one up because the geometric's a little bit easier to come up with. Right, I use my sequence formula. I'm going to put that right next to sigma here because I don't have any simplifying to do. So my first term is 3. We just said our common ratio is 2, and that's to the n minus 1 power. Let's figure out how many terms we're adding up. We're starting at the first term, n equals 1. We have first, second, third, fourth, fifth. That's it. That's sigma notation. So you can quickly take that expression, type it into your calculator. So we're adding from the first term to the fifth term. Starting at 3, multiplying by 2 to the x minus 1 power. And you should get a value of 93. All right, that's the whole thing. All next one here. Negative 18 plus negative 26 plus negative 34 on our way up to negative 66. Well, let's see. This one actually turns out to be arithmetic. Okay, so we're going to use the a sub n formula. And it turns out that to get from negative 18 to negative 26 to negative 34, you're actually subtracting 8 every time. So that's your common difference. So let's first come up with our formula for a sub n. Right? So we have a sub n equals. Our first term is negative 18 minus the common difference of 8 times n minus 1. So I go ahead and I simplify this here. I have negative 18 minus 8n plus 8. And I can combine those like terms to give me negative 10 minus 8n. Well, that's good so far, because what that gives me, I'll write it off to the side here, we can do a little bit more work, is that I know what's going to come after my sigma, right? I'm going to have the negative 10 minus 8n. I just don't know what my index values are. I can assume that negative 18 is my first term, so that's n equals 1. But I don't know what is n for the term negative 66. So you have to do a little bit more work this time. You're going to treat negative 66 as a sub n in your formula and solve for n. So I would take negative 66 equals that expression you just wrote. Right? Because now when I add 10, I get negative 56 is negative 8n, and I can divide to get n is 7. So negative 66 is the 7th term that we are adding up to in our sequence. So that is the top index there. Well, now you can go ahead and type that into your calculator. We're going from 1, so we just found out the 7th term of the sequence negative 10 minus 8x. And you should get the value of negative 294. Okay, so this is what we're looking for. Hope the video helps. Make sure you can find the sums by hand. That means using the series formulas like we did back on the front here. To be able to use these formulas, you can also be able to use your calculator. And if you have any more questions, look at the key that's posted on campus.